A few days ago, I saw a crypto blogger publish an article where he validated a very interesting investment approach. By analyzing holders of successful projects, like Aster, he discovered what other targets smart money is still positioning in. His validation process was very detailed, getting the top 100 holder addresses from BSC Scan, manually filtering out effective smart money wallets, then checking each address one by one on DeBank to view their other holdings, and counting which other tokens appear frequently in these wallets to discover potential investment opportunities. This author documented his manual operation process in detail in the article. After obtaining Aster's top holder data, he performed smart money wallet filtering. The filtering criteria had many rules, removing official treasuries holding over 10%, excluding exchange addresses like Gate, MainXC, Binance, filtering out project wallets like Safe and Treasury, and finally only keeping addresses with holdings over $1 million. Then he had to copy each address to DeBank to check holdings one by one. He said this was purely physical labor, querying addresses one by one until his eyes were strained. I calculated that the entire process would take at least half a day. Although the author ultimately discovered some valuable patterns in AI provided good investment advice, the problem was obvious. If you want to do this analysis regularly or analyze multiple projects, manual operation is simply unrealistic. Moreover, markets change so fast that by the time you finish manual analysis, opportunities might have passed. So I thought, could we completely automate the logic he validated? Let the system automatically filter addresses, automatically query holdings, and automatically generate analysis reports. I chose to use the Inventor platform's workflow to implement this automation process, mainly because its visual interface is very intuitive and does not require writing too much code. My overall architecture design is like this. Scheduled trigger automatically starts the process. HTTP request nodes call Morales API to get holder data. Code nodes implement the author's filtering logic, batch query each address's complete holdings, and finally use AI to generate analysis reports and push to Telegram. Basically, I completely replicated his manual process as an automated workflow. First, build the data acquisition part. I drag in a scheduled trigger node, set the rule to interval mode, set the day interval to 1, and trigger time to 0 to O daily. Everyone can choose different time intervals according to their needs. Then add an HTTP request node. Select Get for the request method and fill in Morales's holder query interface URL. Here we set the query token address as an external parameter contract address, so we can change to query the latest hot tokens at any time. In the query parameter section, add 3 parameters, chain set to BSC to specify Binance Smart Chain, limit set to 100 to get the top 100 holders, order set to DSC to sort by holding amount in descending order. In the request header section, set accept to application JSON and X API key to your Morales API key. This step is equivalent to automating the author's manual process of copying addresses from BSC Scan, and the data is more accurate without human omissions. Next is the most critical part, converting the author's filtering experience into code logic. Referencing the author's original logic, we made some modifications and improvements to the filtering criteria. Here I add a code node with run mode set to process all items once. First, write an ICE-institutionalable function to identify institutional addresses, defining a keyword array containing words like exchange, Binance, treasury, foundation, etc. Check if the address label contains these keywords to determine if it is an institutional address. Then set the main filtering conditions, holding percentage less than 5% to exclude project large holders. Address label is empty or does not match institutional keywords. USD value needs to be greater than $1 million. Finally, iterate through all holder data, add addresses meeting smart money filtering conditions to the address array. Output format as JSON objects containing owner address field. These rules define filtering criteria, but implementing with code ensures consistent standards every time. After filtering out smart money addresses, we need to query the complete holdings of each address. Here I added a loop processing node, setting batch size to the length of all input items, so it can process all addresses at once. Inside the loop, add an HTTP request node, select Get for request method. URL uses Morales's ERC20 query interface with a dynamic parameter JSON owner address. This way, each loop iteration will automatically replace with the current wallet address being processed. Set query parameters chain to BSC, limit to 100. Note the API call frequency limitation. If there are too many addresses, you might need to add delay control. This process completely automates the author's most time-consuming step, previously requiring manual copying of addresses to the bank to check holdings. Now the system can complete hours of work in just minutes. After the loop completes, add a second code node to process all holdings data. I defined a filter tokens function to classify and process each wallet as token holdings. First, perform data cleaning, filtering out stablecoins like USDT, USDC, buzzed, and tokens marked as possible spam. Then classify by 3 dimensions. First category is high security tokens, with filtering conditions of security score CV90 and verified contracts. Second category is big holding tokens, meaning large position tokens with filtering conditions of holding percentage 0.1% and security score Fund 80 for potential coins. Third category is medium risk tokens with filtering conditions of security score between 60-85 and verified contracts. Finally, use for each loop to process all wallet data, aggregating results into the result array. Then design a statistics code module to count the appearance frequency of each token in smart money wallets, so we can find the most watch targets. This classification logic is more systematic and standardized than the author's manual analysis. With the classification statistics results, I integrated Claude AI to generate professional analysis reports. First, add an AI agent node. Select Claude Sonnet 4 model. Then design detailed prompts. The prompts include complete data structure descriptions, telling the AI how to understand the meaning and investment logic of the 3 token categories. I require AI to output in Telegram HTML format. The AI will combine the latest market information to provide specific investment advice, position allocation, and risk warnings for each category. The generated reports not only contain token statistics data, but also investment logic analysis and market judgments, making them more professional and comprehensive than manually organized results. Finally, configure the Telegram push node to complete the entire workflow. Select Send Message for operation type, set Chat ID to your channel, or Group ID select HTML for parse mode to support formatted display. Message content references the AI agent node's output results. After configuration is complete, the entire workflow can run automatically. From scheduled trigger to final report push, the entire process takes only a few minutes, but covers the author's half-day manual workload. More importantly, this system can automatically update regularly, can analyze multiple projects simultaneously, and can ensure consistency of analysis standards. Efficiency improved dozens of times, and accuracy is also higher. Let us look at the actual running results. Click Execute, and you can see each node processing data in sequence. After a few minutes, I received a complete analysis report, including 3 categories of investment advice, appearance frequency of each token, and detailed AI-generated analysis. Comparing with the analysis results in the author's article, our automated system not only covers his discoveries, but can also provide more dimensional data and more timely updates. There are several technical points to note during the construction process: API call frequency control, accuracy of address label recognition, optimization of data filtering thresholds, etc. For further optimization, we could consider supporting more chains, adding price monitoring functions, or optimizing AI analysis logic. The key is to understand the core thinking the author validated, then use technical means to amplify this advantage. Through this project, we completely automated the investment approach the author manually validated. I will share the complete workflow configuration with everyone, hoping to help more people use technology to improve their investment analysis processes.